So hello everyone. In previous video we saw how to design the priority encoder for cross 2. So in this video we are going to design 2 cross 4 binary decoder. So you have to click on add sources, then you have to create add or create design sources, then we have to click next, and then we have to click on create file, and then we have to select the file type as VHDL, and then file name will be encoder 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 4 cross 2. No, encoder will be encoder priority encoder is already done, so we have to do decoder 2 decoder 2 cross 4. Okay, and then we have to click OK, and then we have to finish, and when you will finish you will get to select the ports. So here we can see that there are 2 input ports and 4 output ports. So we can take the input ports as suppose we are taking the input ports as D D, since D input and it is of 2 bits, so here we will write 1, and suppose we are taking the output as Y, and direction will be out, and again we have to click the bus, and it is of 4 bits, so we will take 3. So now we have to click OK. So when you will click OK, here after a few moments you can see that a file will appear decoder 2 cross 4 in design sources. So double click on it, you will see a code window on the right side. So clear this window and write this code. So you have to write this code, import the libraries, and here we can see that we declared the port as D, so we will change it to D as 2 input ports, and one will be the enable input. Also in decoder there is an enable input. If enable is 1, then the decoder is on. If enable is 0, then the decoder is off, and the output is denoted by Y, and it is of 4 bits, that is 3210, Y3, Y2, Y1 and Y0. Similarly, input is, there are 2 inputs, D1 and D0, and here the entity is been declared, entity decoder 2 to 4. Again here we can see that we have named the file as decoder 2 cross 4, so here we have to write decoder 2 cross 4, and similarly here also we need to write decoder 2 cross 4, and here also we need to change it to decoder 2 cross 4, and few of the more changes are needed. Here we have to write D since we have made it D. Okay, so no more errors we can see, and this is the Y init. So we have defined a signal Y int. It is also it is representing the output of the decoder, that is Y, that is of 4 bits, 3 down to 0, and here the output Y int will be 00001 when the input is 00, and it is 0010 when the input is 01. It is 0100 when the input is 10, and it is 1000 when the input is 11, and it is 0000 when the input is other than these 4. And after getting this Y int, this Y int is being inputted to the Y. So here Y is assigned the values of Y int. When should this be assigned? It should be assigned when the enable is 1, else Y should be 000. So the output will be this Y int when enable is 1, and output will be 0 when enable is not equal to 1, and hence our code is being completed here. So we will save, When you will save it, then here we can see a reload button is appearing, so we have to click the reload button. So click on the reload button, and after clicking the reload button, we have to go to sources, and then we have to right click on decoder 2x4 file, and we have to set it as top. Okay, so set as top the decoder 2x4. Here we can see when you will set the decoder 2x4 as top, you will see a symbol appearing here. Okay, similarly in simulation 1 also you have to set decoder 2x4 as top. Right click on it and set as top. Okay, after setting as top, again we can see the reload button, so again you have to click the reload button. So after clicking the reload button, we will go for the schematic. So for schematic, we have to go in RTL analysis, and in RTL analysis you have to click on open elaborated design, and then click this arrow, and then we have to click the schematic. So when you will click the schematic, we can see that here the input is D1 and D0, and one enable input is there, and here we can see that four outputs are there: Y3, Y2, Y1 and Y0. And here in between some circuit is there, so you have to take, if you want to take the screenshot you can take it. Now we have to run the simulation. We have to click on run simulation, then click on run behavioral simulation, and when you will click the run behavioral simulation, we will get a waveform window, the waveform for input and output. So here we can see that how many inputs are there. Two inputs are there, D1, D0, and one enable input is also there. And how many outputs are there? Y. So Y3, Y2, Y1 and Y0. So there are four outputs: Y3, Y2, Y1 and Y0. And this is the signal, so we can ignore this signal. We have to only focus on two things, that is input and the output. So here we have to set each and every bit of D, that is D1. So we have to right click on it, and then we have to click the force clock, and we have to take it as binary, and the leading edge will be 0 and the trailing edge will be 1, and here we can take it as 400 and click OK. And similarly D0, again we have to do the force clock, and then we have to select binary, leading edge 0, trailing edge 1, and the half of the previous one, that is 200 nanoseconds, and then we have to click OK. And similarly enable input, for enable input we have to click on force clock, then we have to click the binary, and then we have to take 0 and then 1, and then we have to take 100 nanosecond, that is half of the previous one, and then we have to click OK. After doing this, we have to take double of the highest time period, that is 800 nanosecond, and then we have to click, and we have to click run for 800 nanosecond. When you will click run for 800 nanosecond, we can see, and then we have to come here and click zoom fit. When you will click the zoom fit and zoom it, click the zoom button, you will get the waveform. So now if we click anywhere in the waveform, we can see that for input 00, for input 00, the y0 should be high. Similarly for input 01, the one input should be high, y1 should be high, but we can't find high. Why? Because enable is 0. When enable is 0, then the output y should be 0 0 0 0. Okay, so thank you.